All right, we are still in our unit that's working on solving systems of equations. You know, substitution, elimination, and we are still working on three equations and three unknowns, triple systems. So let's spend one more day just having some practice on that. So look at number 13. We have our choice whether we want to use substitution or elimination. Um, Looking at all these problems that have, like for example, I see the y, and it has a nice lack of coefficient. There's no number in front. So I could get y by itself very easily. Or this x right here, I could get that by itself very easily. So, and see how short these little equations are? So using substitution would be very easy to do. So that's what I'm going to do. Specifically, I think I will go ahead and get x by itself. This will be the one that I start with. Alright, so if I do that, that'll be, I'm going to let that be a purple equation. Okay, so my starting with this equation, so I've got x minus 2z is equal to 4. So I'm going to do this one by the substitution method. So the first thing to do is to get one variable by itself. I've chosen to get x by itself. So I could just add 2z to both sides like this. Alright, so those go away. So that's going to leave me with x equals 2z plus 4. Okay, so that leaves me ready to substitute this into the other two equations. So I need to set up to substitute into the other two equations. I'm going to do this equation in blue. So that would be like starting off with 4x plus y equals negative 7. I just copied it down. And you know what? Normally I would substitute into the other equation as well. But the other equation doesn't actually have an x in it. So I can't do that. I am going to write it down just in case I need it later. Okay, so I'm just going to put a box around this. So I've got 3y plus 2z is equal to 8. Now, I'm going to take the stuff that I got by itself and substitute it into the blue equation. So I'm going to put x right there. So the blue equation is going to become 4. Now, I'm substituting for x, so it's going to be 2z plus 4, right here where the x was. Okay, and that's going to be plus y is equal to negative 7. Alright, so that is going to give me, if I distribute, I'll have 8z plus 16 plus y is equal to negative 7. Alright, I'll just go ahead and write this in standard form. I could subtract 16 from both sides, for example. So that'll give me 8z plus y is equal to negative 23. Alright, so I've got this blue equation right here ready to go, ready to do stuff with. And the red equation is already ready. Okay, so now what I need to do, if you look at the blue equation and the red equation, look at the variables. I have y and z in the blue equation. And in the red equation, I have y and z as well. Alright, because I got rid of the x's. So I should be able to take these two equations, the red and the blue, and kind of put them together in some kind of way in order to solve for y and z. So let's do that. Okay, so what I could do is see how this y term has a leading coefficient of 1. It's basically by itself. It would be easy to isolate the y on one side of the equation. So I could subtract 8z from both sides, okay, and that's going to give me y equals negative 8z minus 23. Okay, so I can take all of this and I can substitute it into the red equation for y. So if I do that, I'm going to have 3 times parentheses plus 2z equals 8. All right, I just recopied it without the parentheses. Okay, now in the parentheses, of course, I'm going to go ahead and put my negative 8z minus 23. So after our little distributive property, we're going to have negative 24z minus 69 plus 2z is equal to 8. We've got some like terms here with the negative 24z and the 2z. So we can put those together. So that's going to make negative 22z minus 69 is equal to 8. Then I would add 69 to both sides. So that's going to give me negative 22z is equal to 77. All right, and then it's just time to divide both sides by negative 22. So dividing both sides by negative 22, that is going to give me z equals negative 3.5. All right, we don't often get decimals because we've been taking baby steps, but sometimes the answer will be a decimal, so do not be afraid. Now that I have z, I can take that and plug it in, substitute for z here. So that's going to make y come out to be y equals negative 8 times negative 3.5 minus 23. So that is 5. So y equals 5. All right, and now we can find x because I can take this y. No. Okay, I need x, but I have x right now in terms of z. So I won't take the y. I will take the z, and I will plug that in, substitute. So I will take this z all the way around like this and substitute for z. So that gives us x equals 2 times negative 3.5. Okay, plus 4. So that is negative 3. So x equals negative 3. All right, now we found all 3 solutions, all 3 values. So let's go ahead and record the final answer as an ordered triple. And it will be in the form x, comma, y, comma, z. So this would be how you would write the solution for number 13. All right, let's go ahead to number 14. Let's see, were we told which method we had to use? Or can we just do any method? Let's look back. So use substitution or limit. So we can do whichever one we want this time. Okay, I'm really feeling elimination on this one. The reason why is because look right here. If I target the z's, if I put these together, those are already opposites. And then later, if I put these together, they're opposites again. So this is going to be really easy because I won't have to multiply by anything. So this is what I'm going to do. Like I just mentioned, I'm going to target the z's. Okay, so keep your eye on the z's throughout this process. And let me just label that I am doing the elimination method. Okay, gonna do the elimination method. So what I'm gonna do is I'm gonna go ahead and use the first two equations and pair those up. And then I'm going to use the last two equations and pair those up. Again, it doesn't have to be the first two and the last two. I could have used, for example, the first and the third if I wanted to. So I like to just recopy so everybody can follow. So the first two equations are x plus y plus z equals 3, and x plus y minus z equals 3. Seeing a lot of similarity. Something strange is probably about to happen. Okay, so that's the first pair. Let me go ahead and set up the second pair. Alright, so the second pair I will show in red, looking at this bracket. So that would be x plus y minus z is equal to 3, and 2x plus 2y plus z is equal to 6. Alright, so these are the second two equations. Now, like I mentioned, we already have the z's are already opposite, so I don't even need to multiply. I can just start combining like terms. So if I put these together, I get 2x plus 2y is equal to 6. I won't leave it like this. I like to make everything as the numbers as small as possible. And I noticed that everything is divisible by 2. So I would recommend, okay, let's go ahead and divide everything by 2, okay? So divide by 2 like this. So that's going to give me x plus y is equal to 3. Alright, so this is the blue equation that I will save for later. Now I will do the similar thing with the red equations. Combining like terms, I get 3x plus 3y. Z's go away. And that's going to be equal to 9. I'm noticing that all of these are divisible by 3. So I'm going to go ahead and do that. Make the numbers smaller, okay? So divide by 3 here, here, and here. So that is going to give me x plus y is equal to 3. Like that. I told you something strange was about to happen. It's the same exact equation. So that already tells me that this is going to be infinitely many solutions. I'm sort of picturing the graphing method when I say that, because I know that if I put these together, if I were to graph them, since they're the same equation, it would be the same line twice. And that's what happens for infinitely many solutions. If you did try to follow through and set these up on, by making two equations And continuing with the elimination, watch what would happen. So I've got the blue one, and here's the red one. You know, same equation. But as soon as I tried to multiply by something to get opposites that would cancel, you can already imagine what's going to happen. So for example, say if I decided to multiply this bottom equation by -1, then what I'm going to get is, alright, I've got x plus y equals 3 from the top equation, but then I've got -x minus y is equal to -3 from the bottom equation. Okay, so if I combine those like terms, I am getting, you know, everything cancels out. That means I have 0 equals 0. And when everything cancels out and I'm left with a true statement like 0 equals 0, that's when we know that there are infinitely many solutions. Alright, and I want you to say this exact phrase. Don't just say infinite, say infinitely many solutions. Whoops. Alright, and that would be your final answer for this problem. Okay, let's see what is next. But again, as soon as you see that it's the same equation twice, you know it's going to be infinitely many solutions. Alright, number 15. I'm going to do this one by substitution. Okay, I'm going to pick substitution. See, I've got this short little equation. That's usually a good sign. I'm going to use substitution. See how this variable x is the one I'm liking the most because it's part of a little tiny equation and it's got no coefficient. Well, the leading coefficient is 1. So, in fact, that is where I'm going to begin this journey. Alright, I'm just going to recopy this equation down here. So I've got x minus 3y is equal to 0. Alright, getting this x by itself, that's why I highlighted it, I could just add 3y to both sides. So that's going to give me x equals 3y. Okay, cool, man. That means this is already by itself. I feel like using a square. So this is one little equation that I have. Now, substitution. So I need to take this and substitute it into the other two equations. So let me just color coordinate. So I'll let this equation be my blue equation. So that's going to be 2x plus 3y plus 3z is equal to 18. And I'm going to let this be my red equation. So that's going to be x plus 2y minus 4z is equal to 10. Alright, so now I have to take what x equals and substitute it into both of these equations. So in other words, I'm doing this. I'm putting x here. That's a bootleg arrow. But I'm also going to put it here. Alright, so let's see what happens. Start with the blue equation. Okay, so 2x. Here's where I'm substituting in 3y. So this is going to be 2 times 3y plus 3y plus 3z equals 18. So that's going to give me 6y plus 3y plus 3z equals 18. Like terms here, So that's going to give me 9y plus 3z is equal to 18. All right, that's about as far as I can go with this for now. Let's put a box around it. Let's do the red equation now. So switching to red, again I'm substituting 3y for x. So that's going to give me 3y, okay, plus 2y minus 4z equals 10. So putting these like terms together, that's going to give me 5y minus 4z is equal to 10. Look, that's as far as I can go with that equation. So I'm going to go ahead and put a box around that and use it later. Back on the blue equation, did anybody notice this? I missed it at first, but I'm thinking about it now. I'm actually going to take this box away. Can anyone guess what I'm going to do with this blue equation before I put a box around it? You know how I'm always telling you guys to make the numbers smaller if you can. Look for that common factor, the GCF if you will. All three of these terms are divisible by 3. So it will make your life easier if you divide all three terms by 3 before you carry on with the problem. So this will be 3y plus z is equal to 6. Okay, so smaller numbers, easier to work with. Okay, so now I have these two equations. They both are yz equations. So what you do is you take these equations, put them together, and solve it out. So if I do that, okay, so I've got my 3y plus z equals 6. Just copied it down. And I've got my, I'm just going to copy this down. So I've got my 5y minus 4z is equal to 10. Alright, I'm using my two boxed equations to make a brand new system that I will now solve. Okay. I need opposites that cancel. I think the easiest thing to do would be to make the z's cancel out. So in order to make those z's cancel out, I am going to multiply by 4, the top equation by 4. So that is going to give me 12y plus 4z is equal to 24. Now the bottom equation, I'm just going to recopy it the way it is. So that's 5y minus 4z is equal to 10. Okay? So if I put these together, that's going to be 17y. These are gone. And that's going to equal 34. Alright? Now I can divide by 17. Alright, so dividing by 17 on both sides. That's going to give me y equals 2. Alright, so y equals 2. That's one of my answers. Now, whenever we're solving a normal system that has two variables, as soon as I find one, I take it and I substitute it back in and I find the other one. So that's what I'm gonna do. Okay, so I could pick either one of these two equations. Whoops. I'm just going to pick the blue equation because it looks pretty easy. And I'm going to recopy it because it helps me stay organized. So the blue equation is 3y plus z is equal to 6. Okay? But I'm going to take this y value of 2 and I'm going to plug it in like so. Alright, so that's going to make this become 3 times 2 plus z is equal to 6. Interesting. So that's 6 plus z equals 6. Subtracting. So that gives me z equals 0. So that is my second value. So I have y, I have z, all I need is x. Well, look, right from the beginning I had this little x term, x equals 3y. And now I know what y is, so I could definitely plug that in. So I'm going to take this y value of 2, and I'm just going to substitute it for y like you do. Alright, so that's going to give me x equals 3 times 2, which of course is 6. So now I have all three of the values, x, y, and z. So if I record my final answer as a nice ordered triple in the form x, comma y, comma z, then this is what I should have. Alright. Okay, so that was number 15. Let's do number 16. Number 16, let's see. I'm going to go back to the elimination method for this one. Okay, let me help you see what I see. Do you see what I see? I have, look at this, I'm seeing this z here and this negative z here. I like the fact that they're already opposites. So I would love to make sure I put those together when I make my pairs. So I'm going to make sure that the first equation and the third equation are one of my pairs. So those are already ready to go. And the other two don't really matter. So I'll just pick the top two. So these will be my blue equations, and then these will be my red equations. Okay, so here are my blue equations recopied. So I have 4x plus y plus z is equal to 5, top, and I have 3x plus 3y minus 2z is equal to 22. Alright, let's go ahead and solve this. Okay, I can solve this by, if I want the z's to go away like I have chosen, then I need to multiply by 2 here, which means I have to multiply everything by 2. So the new blue equation will be 8x, alright, distributing, plus 2y plus 2z equals 10. Okay, I'm just going to recopy the bottom equation. So I've got 3x, plus 3y minus 2z is equal to 22. When I combine these like terms, this is going to give me 11x plus 5y, these are gone, is equal to 32. Alright, I don't see any common factor, so I'm going to go ahead and put a box around this and save it for later. Let's do the same thing with the red equations. So the red equations are 4x plus y plus z is equal to 5. That's the top equation, and the bottom equation is the other one. So x minus 2y minus z is equal to 3. Alright, I love this one because it already has opposites, so I don't even have to multiply. That's nice. So that's going to give me 5x minus 1y is equal to 8. Yep. No common factors, so I'm going to put a box around this one and save it for later. So the two box equations are the ones that I will use to solve for x and y. So, okay, let's go ahead and do that. Let's see, which one do I want to put on top? Not that it really matters. I guess I usually do blue and then red. So I'm going to take this blue equation and just stack it up. So that's going to be, 11x plus 5y is equal to 32. All right, that's the blue box. And now here's the red box equation. So that's 5x minus y is equal to 8. All right, so as I go ahead and solve this new system, the red and blue system, and notice red plus blue make purple, so that's why I always do purple when I put these together. All right, I'm just cool like that. So if I want, I'm liking these y's to cancel. All right, I can change this into a -5 just by multiplying by, you know what, I think I used to pick the middle one. By multiplying by 5. So if I multiply by 5 right now, then, okay, I have my new system. All right, I better check this text because it will not stop ringing if I don't. Okay, so that's going to make, the top equation stays the same. So there's my 11x plus 5y is equal to 32. The bottom equation changes. So that's going to be 25x minus 5y is equal to 40. Okay, so as I combine these like terms, I'm going to have 36x, the y's are gone, and that's going to equal 72. All right, of course, now I'm going to divide by 36 to get x by itself. All right, so if I divide by 36 on both sides, then that's going to give me x equals 2. All right, so there's my first value that I get to keep, x equals 2. All right, so I found x. So before I go back to anything else earlier, I'm going to stick around and find y. You know, I can use either the blue equation or the red equation to substitute into. I'm going to go ahead and use the red equation to get that done. It just looks simpler to me. So the red equation here, you know, I'm just going to recopy it like I do. All right, so the red equation is this 5x minus y equals 8. If I substitute this x in there, then that's going to give me 5 times 2 minus y equals 8. So that's 10 minus y equals 8. And if I subtract 10 from both sides, I have negative y equals negative 2. So that's going to give me y equals positive 2. Okay, and that's another value I can keep. Of course, you know, just to be clear, don't want to skip any steps and confuse anybody. I can't leave this negative y, so the way I fix it is I divide both sides by -1, which just changes the signs. So now I have an x and a y. So now I just need to find a z. So I need to find myself an equation that has a z in it and use it. Okay, do it. So that's what I'm going to do. Let's see. I think I'll do it over here. So I have to go back to the beginning because these are the equations that have z's in them. So I'm just going to pick one of these three equations, whichever one looks simpler, and I'm going to substitute the 2 and the 2. Let's see. The top equation looks the simplest to me. So that's what I'm going to use. Okay, so I'm just taking this equation and I am bringing it down. Okay, so I have 4x plus y plus z is equal to 5. All right, but now I know that x and y are both 2. So this is going to make 4 times 2 plus 2 plus z is equal to 5. So that's going to make 8 plus 2 plus z equals 5. Putting these together, that's going to make 10 plus z equals 5. Subtracting 10 from both sides, that's going to give me z equals negative 5. And that is the third and final value. Alright, so as an ordered triple, the solution is 2, comma, 2, comma, negative 5, x, y, and z. Alrighty then, that is the answer to number 16. Let's take a look at number 17. I think this is the last one. Yep. Alright, this is the final problem. Okay. This is a real world problem. A lot of words, but I think it won't be that bad if we can just break it down. Let's scan through the problem and see what we're dealing with. Myra is selling 3 types of candy: sour sillies, choco nuts, and almond clusters. On the first day, she sold 2 sour sillies, 4 choco nuts, and 1 almond cluster, making $10. On the second day, she sold 1 sour sillies, 2 choco nuts, and 3 almond clusters, making, again, $10. On the third day, she sold 12 sour sillies, 4 choco nuts, and 6 almond clusters. She made $30. Find the price of each type of candy. Well, you hear the 3 days, so those 3 days are probably going to be the 3 equations. But let's start by defining our variables. It's always a good place to start, ladies and gentlemen. Okay, let's see, what do they say? This last sentence will really tell you what your variables need to be. Find the price of each type of candy. Okay, the price of each type of candy. That's what the variables need to be. Let's see, sour sillies, choco nuts, and almond clusters. So I will use S, and you know what, I'm going to write this down off camera to save time. Okay, so here I have defined my variables. Alright, S for the price of sour sillies, C for the price of choco nuts, and A for the price of almond clusters. Now let's get those 3 equations going. It just looks to me like there's going to be 1 equation for each day. Okay, so what do they say? On the first day, she sold 2 sour sillies, 4 choco nuts, and 1 almond cluster, making $10. So that equation would look just like this. Whoops, did not mean to do that. Okay, so 2 sour sillies, 4 choco nuts, and 1 almond cluster. Total money is $10. Okay, this makes sense because S, C, and A are the price of each candy. So 2 times this amount of money, 4 of this amount of money, plus this amount of money. It's all money, and this should be a total of $10. So the other equations all work the same way. So, por ejemplo, the next day we have, whoa, I thought I was highlighting, but I got confused. No te confundas. So let's see. She sold one sour sillies, 2 choco nuts, 3 almond clusters, again with the $10. Okay, so now if I want to write this as an equation, 1 sour sillies, 2 choco nuts, and 3 almond clusters, $10. So we need one more equation. Okay, let me go highlighter on it. I feel like pink. Alright, on the third day, she sold 12 sour sillies, 4 choco nuts, 6 almond clusters, and made $30. So, therefore, we're going to need a pink equation. Usually has to be a darker pink though. Let's rock this one. Okay, so 12 sour sillies, so 12S. 4 choco nuts, so plus 4C. And 6 almond clusters, 6A. That's $30. Alright, so this problem was very straightforward in terms of setting it up. And then as far as solving it, I'm just going to do elimination similar to what we've done many times. Now, scanning through this, I really need to see, well, it would be helpful to me if I target a variable that has no coefficient. So you probably see the one variable that I've got, this s right here. So because of this s, and this is the only variable that doesn't have a coefficient other than 1, these are the variables I'm going to target in that case. I'm going to target the s's. Alright, so I'm going to do what I've done many times before. And I'm going to make a new system out of the top 2 equations. And then I'm going to make a new system out of the bottom 2 equations. Okay. Alright, so I'm going to make my blue equations and my red equations. You've seen me do this many times by now. So the blue equations are 2s plus 4c plus a equals 10. I just copied that first equation. And s plus 2c plus 3a equals 10. Copied it. Alright, I want to solve it. Remember, I'm targeting s. So I'm going to multiply the bottom equation by -2 to make these cancel. Alright, so the top equation, I'm just going to copy it again. So 2s plus 4c plus a is equal to 10. But the bottom equation becomes -2s, okay, minus 4c, okay, and this is going to be minus 6a. And this is going to equal -20. So if I put this together, I get a bonus, okay, because the s's cancel out. But it turns out the c's cancel out as well. I like it. I'm liking it. So this is going to make -5a is equal to -10. So I could keep going, dividing by -5. Okay, so that is going to give me a equals 2. Alright, so that is one of the values that I need. Alright, remember what this represents. A is the price of almond clusters. So I found out that almond clusters cost $2. All right, I gotta pause this video because the bell rang and my 5th period class is about to come in. So I will finish this video at home, hopefully not at 2 a.m. like I did last time. Crazy Burton. All right, peace out for now. So at this point we've done the 2 blue equations. And we got a bonus, and we got all the way down to an actual answer, which usually doesn't happen. But now it's time to go back and do the 2 other equations, which I'm going to color red, the bottom 2. So as I like to do, I'm just going to recopy. So it's this. So we have S plus 2C plus 3A is equal to 10. And then I have 12S plus 4C plus 6A is equal to 30. All right. Now remember S, that's what we have to target since that's what we eliminated in the previous equation. So if I target that S, it would be helpful if this were a negative 12. But you know what I'm seeing? That just makes me want to change the values a little bit. Look at this pink equation. 12, 4, 6, 30. All of those are even numbers. I don't really, maybe I should leave it alone. I don't want to confuse you guys. Alright, I was getting ready to reduce these because I want the numbers to be as small as possible. So I'm tempted to divide all of these numbers by 2. But I'm afraid I'm going to confuse somebody, so I won't do that. Instead, I'll just do the usual thing that you do, which would be to multiply the top equation here by negative 12. So I will have opposites. Okay, so fine. My numbers will be a little big. So this is going to give me negative 12s minus 24c minus 36a is equal to negative 120. That's from multiplying the top equation by negative 12. The bottom equation, I'm just going to bring it down. So 12s plus 4c plus 6a is equal to 30. As I combine like terms, these go away. So I will have negative 20c minus 30a is equal to negative 90. Okay. All of these are divisible by 10. So I'm definitely going to do that at this point. Make the numbers smaller. Life is better. So if I divide all of these by 10, okay, then the red equation becomes, oh, you know what, I said 10, but then I did. You know what, just for fun, I am going to divide them all by negative 10. I put the little minus here. If I divide by negative 10, everything will even turn positive, which makes me happy. So, so this will be 2c, positive 2c. This will be positive 3a. And this will be positive 9. See, I divided everything by negative 10. Now this is a much friendlier equation, so I like it. Now, I've got the red equation. That's as far as it can go. I put it in the box. But I had this blue value that I found when I did the blue equations. So it would be smart if I go ahead and take this and substitute it in right now. So that's going to give me 2c plus 3 times 2, because that's a, is equal to 9. So that's 2c plus 6 is equal to 9. All right, subtract 6 from both sides. That gives me 2c is equal to 3. Okay, and that is going to give me, okay, if I divide both sides by 2, like so, then I'm going to have 3 over 2, which as a decimal is 1.5. Always makes me nervous when it's a decimal. I have to look back, see if that makes sense. So c is 1.5. Now, what are these variables again? The price. These are prices. So 1.5 means $1.50. Okay, that's really what that means. And then that could be true. Should I cheat and check the answer key before I go any further? All right, so I've got a equals 2, c equals 1.5. Let's cheat and look at the answer key, shall we? I don't want to do this whole problem. Oh, you know what? There is no answer key. I haven't. I guess I'm making that answer key right now. Let's just hope I'm doing it right. So c equals 1.5. Own it. Now I have two values. I have a, I have c. I still need to find s. But once you have two values, you really can go back to the beginning and pick any of these three original equations. I like the green equation, so I'm going to use that. Okay, the green equation, maybe I can even copy it. Okay, I've got the green equation. I'm bringing it down. Bam! Okay, I even got this highlighting. Don't really need that highlighting. Okay, so here's the green equation. But I've got two values here, so I can take a and put it in there. And I can take c and put it in there. Okay, let's see what happens if I do that. Alright, so that's going to give me s plus 2 times 1.5 plus 3 times 2 is equal to 10. Okay, so that's going to give me s plus 3, all right, 2 times 1.5, plus 6 is equal to 10. Combining these is going to give me s plus 9 is equal to 10. Subtracting 9 from both sides, s is equal to 1. Okay? Now we just have to translate this all back into words, which I think I'll put right here. So translating these values back into words, which you must do. Do not just leave it x, y, and z, or even a, s, and c for a word problem. Sour sillies cost $1. That's this. Choco nuts cost $1.50. That's this. And almond clusters cost $2. That is this. All right, and that is the end of problem number 17 and the end of this lesson.